All right, we're going to do our last topic for this radical unit, and what we're going to look at is radical equations. So it's quite a bit different than what we've been doing before, and most people find this quite easy. So it's just solving equations like you've been doing before. The only thing different now is we get a square root involved. So when you have a radical in the equation, what we want to do is try to isolate that first. And the logic is if we can have a square root of something by itself, we can get rid of that square root by squaring it. We just saw that if we have root 3 times root 3, that's the same thing as root 3 squared, and that ends up just being equal to 3. So that's our goal with radical equations, is to try to get that square root gone, and to do that we just need to isolate it. So our first trick then, this is the same question from the title page. So if we look at the title page, you see we got an answer of 118. So let's go through this one to see if we can get that. So the first step is isolate the radical. So we want just the radical by itself. So in this case, we need to get rid of the 2. So if we add 2 to both sides, we get root x plus 3 equals 11. Now we have the square root by itself, so now we can just square both sides. So that will give us x plus 3 equals 121. And then our last step is we want to get the x by itself. So if we subtract 3 on both sides, we get x equals 118. So that is the answer, and we did it, and it was pretty easy. So the only thing you got to do now is you want to double check that answer back in the original equation just to make sure it actually works. Sometimes with square roots you'll get an answer that doesn't work in the equation, which we call extraneous. So you just want to make sure that it's actually a legitimate answer. So in this case, if we put the 118 in, we get square root of 121. Square root of 121 is 11. 11 minus 2 equals 9. That's good. So it's worth the time, just do a quick double check, and then you can see if your answer is valid or not. So let's try a couple more. So here's one. Get the square root by itself first. Let's get rid of the 5. So we'll subtract 5. So we'd have 2x minus 1 equals 7. Now we can square both sides. So 2x minus 1 is 49. Now we just solve it like a normal equation. Add 1 to both sides. So we'd have 2x equals 50. And divide by 2. X equals 25 would be our final answer. And if we plug that back into the original, we can double check. So 2 times 25 is 50, minus 1 is 49. Square root of 49 is 7. 7 plus 5 is 12. So that's a good answer. Okay, this next example I got here, we've got a minus 8. So let's add that to both sides to get rid of that. So we have 3x over 5 equals 6. Now we're ready to square both sides. So we have 3x over 5 equals 36. And to solve this one now, we want to get rid of the 5, so we'll times both sides by 5. So that'll give us 3x equals 180. And then our last step is divide by 3. So 180 divided by 3 is 60. So that should be our answer for this one. So if we plug it back into the original, so 3 times 60 is 180. Divided by 5 gives us 36. Square root of 36 is 6. Negative 8 plus 6 is negative 2. So that's a good answer as well. Okay, the only other type we need to solve is if we get 2 square roots. So you can see in these equations we've got a square root on both sides. And in this case, it works pretty much the same. We just want to isolate it, which we do. We have 1 on each side, so that's good. So we're ready to just square both sides the way they are. So we get x plus 3 equals 3x minus 5. So now to solve this one, let's bring the x over first. So we get 3 equals 2x minus 5, and then let's get the 5 over. So you'd have 8 equals 2x. 8 divided by 2 is 4. And we could plug that back into the original. We get root 7 on one side, root 7 on the other. So they're both good. So that's a valid answer. And same thing with this last one. If we square both sides, we have x minus 3. Equals 3x minus 5. And even if they weren't equal, let's just look at it. If this was negative equal to 0, we could move it to the other side first. Then it'd be just like we started with, where they're just equal to each other, and then you could square it. So you don't necessarily have to have 1 on each side, but you want to switch it to that form first if you can. And then that's it. So let's get rid of the x again. So that'll give us minus 3 equals 2x minus 5. We'll add 5 to both sides. So it'll be 2 equals 2x, divide by 2, x equals 1, and that's it. If we plug it back in, let's take a look at that now. So we plug in the 1, we get square root of negative 2. Can't do the square root of a negative number, so that means this answer is not valid. So it would be extraneous would be a way to say it, or just cross it out saying the answer doesn't work because we can't do the square root of -2. So that's the only thing you have to be careful of with the square roots. If you get a negative number, that usually causes a problem. But that's all for this unit.